Topic 4 is on experimental research methodology, which comprises the subtopics of what is an experimental research, what is internal validity, threats to internal validity or the extraneous variables, techniques to enhance internal validity, hypothesis in an experiment. An experimental research is a research method that is used to examine the effectiveness of a particular action, intervention of treatment, independent variable, on the occurrence of a particular change, dependent variable. For example, an experimental research can be conducted to study the effectiveness of computer-aided teaching, independent variable, on the learning of mathematical concepts, dependent variable. The experimental method is the best method to show effectiveness of a particular treatment or intervention, for example, teaching method, curriculum innovation. Experiments are ideally suited for the task of causal analysis, which is establishing cause and effect relationship. The word effectiveness only applies if you are using the experimental method. The figure shows a simple experiment to determine whether the treatment or intervention computer-aided teaching, CAT, causes students to perform well in the mathematics test, which is the effect. The experiment involves administering a treatment, independent variable, such as computer-aided teaching. A pretest, dependent variable, is given before the experiment and the same test or equivalent test is given after the experiment. The differences between the pretest and the post-test mathematics scores will determine whether computer-assisted teaching improves students' performance in mathematics. A key problem in conducting experiments is establishing suitable control so that any change in behavior can be attributed only to the treatment introduced by the researcher. Control means ruling out other possible causes for changes in the behavior of subjects. There are many extraneous variables, irrelevant or unrelated or unconnected factors that need to be controlled so that they do not contaminate or interfere with the findings of the study. Once an extraneous variable creeps into an experiment, the researcher can no longer draw any conclusion regarding the causal relationship that exists between the independent and the dependent variable. Some experiments have both an experimental group and a control group. An experimental group consists of subjects who are exposed to the treatment or intervention, like the computer-aided teaching, CAT. The control group consists of subjects who do not receive the treatment or intervention. For example, the subjects are not taught using the computer-aided method, but using the traditional method of chalk and talk. Comparison between the experimental group and control group determines the effectiveness of the computer-aided teaching method. An important concept in experimental research is internal validity. An experiment has internal validity if the extraneous variables have been controlled or ruled out, and the obtained effect can be attributed to the manipulation of the independent variable. In other words, internal validity is an indication that the results obtained in an experimental study are caused by the treatment or intervention, that is, the independent variable, administered and not some other variables or factors. In the example given, some extraneous variables that might affect the learning of maths concepts other than CAT, computer-aided teaching, maybe some students would have discussed with their friends at school concerning the maths concepts, while others may have viewed a program on the topic on television, or they learned about the topic in their tuition classes. The extraneous variables which are a threat to internal validity are history, maturation, instrumentation, testing, mortality, selection bias, statistical regression, subject effect, and experimental effect. History refers to an unintended learning during the experimental period. Maturation is the biological and psychological changes in the subjects during the experimental period. Instrumentation is the difference in the type or difficulty level of test instruments used in the pre-test and post-test. Testing refers to the situation where subjects become test-wise after the pre-test, or they can recall the answers in the pre-test. Mortality means subjects, especially those of a particular characteristics, example, low ability, drop out of the experiment. Selection bias happens when subjects selected for the control group are different from those selected for the experimental group, giving rise to non-equivalent groups. Statistical regression means that extreme scores, either very high or very low, in the pretest tend to move towards the mean in the post-test. This is known as the ceiling or floor effect. Subject effect is a situation where the subjects who realize that they are involved in an experiment may perform beyond their usual level. This is known as novelty effect. Subject effect also happens when control group subjects perform beyond their usual level to compete with the experimental group. This is known as the John Henry effect. Experimental effect means that the experimenter, who is keen on obtaining positive effect of the experiment, may pay special attention to the experimental group, and this is also known as the Hawthorne effect. There are several techniques to enhance internal validity by establishing equivalence between groups. The first technique is the randomization of subjects. Randomization involves two stages. The first is the random selection of subjects from the target or accessible population to ensure the sample is representative of the target population. The second stage is the random assignment of selected subjects to different treatment groups to ensure that the groups are equivalent. For example, let's take a look at the study on the effect of self-questioning on the reading comprehension of expository text by secondary students. A sample of 120 students is randomly selected from a target population of 400 students. Out of this sample of 120 students, 60 students are randomly assigned to the experimental group, that is reading with self-questioning, while another 60 students are randomly assigned to the control group, which is reading without self-questioning. The second technique to enhance internal validity is matching. The procedures for matching are as follows. First, we give the students or subjects a pre-test to determine their initial reading ability. Second, we rank the subjects based on their reading ability scores. Third, we assign the subjects to matched pairs. For example, the first pair consists of subjects with scores ranked 1 and 2. The second pair consists of subjects with scores ranked 3 and 4, and so on. Finally, we randomly assign one member of each pair to the experimental group and the other to the control group. The third technique is holding one or more variables constant. For example, in an experiment, you have difficulty ensuring that the experimental group and control group have an equal number of good reading ability and poor reading ability subjects. You could take only average reading ability subjects and assign them randomly to the experimental and control group if you are not interested in comparing high and low socio-economic subjects. What you have done is to eliminate the reading ability factor or variable by including only average reading ability subjects, that is controlling by holding reading ability constant across the two groups you are comparing. The fourth technique is including an extraneous variable in the research design. You could control a variable by including it in the design by making it another independent variable. For example, you design an experiment to test the effectiveness of using self-questioning on the reading comprehension of expository text by secondary students. However, you find it difficult to control for reading ability among your subjects. You could include only those who have low reading ability based on a test on reading you administered, or you could categorize reading ability as high, average, and low based on test scores and treat reading ability levels as an independent variable. However, you should use this technique only if you are interested in the influence of reading ability on reading performance. What you have done is to control the influence of reading ability on other independent variables by including it in the design. The fifth technique is using the statistical procedure known as analysis of covariance or ANCOVA. ANCOVA is a statistical method used to ensure that the subjects in the control group and the experimental group are equivalent as various factors. ANCOVA adjusts the scores on the dependent measure for the differences found on the pretest and statistically equates the subjects in the experimental and control group. For example, you are conducting a study on the effectiveness of self-questioning on the reading comprehension performance of Form 4 students. However, you find that some subjects in your experiment are good readers while the others are poor readers, which may influence performance on the reading test, that is the dependent variable. To ensure that all subjects in the control group without self-questioning and the experimental group with self-questioning are equal in the reading ability, the ANCOVA is used to adjust scores on the reading test for difference in reading ability. A hypothesis is a conjecture, guess, or speculation about the presumed relations between variables. There are two types of hypotheses, directional and non-directional. The directional hypothesis states a relationship between the variables being studied or difference in treatments that the researcher expects to emerge. It uses comparative words such as higher, better, greater, etc. Examples: students who receive training in cognitive strategies will score higher in reading comprehension than those who do not receive training in cognitive strategies. Children taught arithmetic using the inquiry method will make greater gains in arithmetic than those who were taught using the didactic method. A null hypothesis is a statement of no relationship or differences among the variables being investigated and is used in statistical analysis. In other words, a null hypothesis is a statistical statement which states that no significant difference or relationship exists. The following examples will illustrate the null hypothesis. There is no significant relationship between students' achievement in English language and their achievement in mathematics. There is no significant difference in achievement between students receiving highly detailed comments in their essays compared to students receiving grades only. Test of significance. The test of significance enables one to determine whether the amount of difference between two groups is due to chance or due to treatment. In the example, the mean difference between the experimental group and control group is 2.1, which may lead us to conclude that the experimental group performed better than the control group because the mean score is higher by 2.1 and so the treatment is effective. This is misleading because it is likely that the differences in the mean between the experimental group and the control group could have occurred by chance. Does a difference between the mean score of the experimental group and control group indicates that the difference is real? Even large differences could occur by chance, although the probability of this happening would be very low. The most common practice to determine whether the difference between the two groups is caused by the treatment or by chance is to state a significance level that must be reached, which is a statement of the probability that an observed difference is chance difference. The most common significance levels are 0.05 and 0.01, regardless of whether you are using the t-test, f-test, or the chi-square. If you decide that the 0.05 significance level is to be used, it means that you will accept as a real difference only one that is so large that it could have occurred by chance only 5 times in 100. Therefore, 95% not due to chance. If the 0.01 significance level is selected, then the difference can be expected to occur only 1 time in 100 by chance. That means 99% not due to chance. The level of significance is denoted by the alpha sign.